Hello everyone, we are solving problems on the Thevenin's and Norton's theorem. In that, case 2 problems are completed. Now we will start case 3. In case 3, circuit contains only dependent sources. Okay, if circuit contains only dependent sources, circuit does not contain any independent sources, circuit has only dependent sources, then this type of circuits or this type of networks are called dead networks. This type of networks are called dead networks. For this, Thevenin equal to, for dead networks, Thevenin equal to 0 volts and short circuit current or Norton current equal to 0 amps. Only Thevenin resistances exist or Norton resistances exist. This is not equal to 0. Now, how to find Thevenin resistance and Norton resistance? You can find by using external source method. You can find by using external source method. Now, we will solve some problems on this concept. In that, first question is, find the Thevenin equivalent across terminals AB for the following network. This is the given network. If you observe this network, there are no independent sources. So only contains dependent source. So this type of networks are called dead networks. To find R Thevenin, so here V Thevenin equal to 0 volts and Norton current or short circuit current equal to 0. To find R Thevenin, connect one external source, let it be V. Due to this external source, current I is flowing through this network. So now what is R Thevenin? R Thevenin is equal to voltage by current, total voltage by total current. You will get R Thevenin. If you observe this voltage source value is V1. Okay, because these two are in parallel. So here it is V1. This node voltage is V1. V1 equal to V. Let it be V2. Write the node equation for V1. This current is coming towards to this node. So it is minus I here plus V1 by 100 plus V1 minus V2 by 50. This is minus 100I. V1 equal to V. In this case, V1 equal to V. So 100I plus V plus 2V minus V2 equal to 0. 100I is equal to 3V minus 2V2. Let it be equation 1. Now, write the node equation for V2. For this node, V2 minus V1 by 50. Here V1 equal to V. So, V2 minus V by 50 plus V2 by 200. This current is going away from this node. So plus 0.1, V1 equal to V, so V equal to 0. 4V2 minus 4V plus V2 plus 20V equal to 0. 5V2 is equal to 16V minus 16V. V2 is equal to minus 16 by 5V. From 1. Okay, this is 1. From 1, 100I is equal to 3V minus 2 into minus 16 by 5V. 100I is equal to 15V plus 32V by 5. If you solve this, R Thevenin is equal to R Norton equal to V by I is equal to 500 by 47 ohms. This is 10.63 ohms. Thevenin and Norton equivalent is like this, because here source voltage is 0. Thevenin voltage is 0, so it is short circuit. Here Norton current is 0, so it is open circuit. This is Thevenin equivalent, this is Norton equivalent. Next question is, the network shown in the below figure acts like, options are option A 1 by 3 ohms, option B 2 by 3 ohms, option C 4 by 3 ohms, option D 8 by 3 ohms. This is the given network. So he is asking R Thevenin or Thevenin equivalent resistance. Here the circuit contains only dependent sources. So apply case 3. Case 3 means apply external source and find R equivalent. This is external source. Due to this external source, current I is flowing through this network. Here, if you observe here, this branch current is I, and similarly this branch current is I1. So both are in series. So here I1 equal to I. Here the voltage is V because these two are in parallel. In parallel, voltage is same. So the voltage source will appear across 4 ohm resistor. Now write the node equation for V. Then you will get this current is coming towards to this node. This is minus I. For this branch plus V by 4. For this branch V minus I1 equal to I. Here this is 2I now. So V minus 2I. V minus 2I by 2 is equal to 0. Minus 4I plus V plus 2V minus 4I equal to 0. 3V equal to 8I. So R equal to V by I is equal to 8 by 3 ohms. Option D is correct answer. Next question is, the Thevenin voltage across AB for the network shown in the below figure. Options are option A 0 volts, option B 3 volts, option C 5 volts, option D none. If you observe this network, here he is asking voltage across, open circuit voltage across these two terminals. Okay, so here the network contains only dependent source. So the Thevenin voltage is 0 volts. Okay, so this is wrong answer, because if you observe this network, here 3 ampere source is coming towards to this node. This is 3I amperes. Now what is the current flowing through this branch? This branch is open circuit, so it is 0 amps. So the entire current should be goes through this branch, but here the current is I. That means this is violation of KCL. Physically connection is not exist. So option is none. Option D is correct answer. Okay, don't take VThevenin equal to 0 volts. Here physical connections are not exist because it is violation of KCL. This current must be goes through this branch. This 3I equal to I. In series current must be same, but here this is 3I and here it is I. So this is violation of KCL. Physical connections are not exist. Option is none. In the next video, we will see some more problems on this concept. Thank you for watching.